Welcome to Ask and Learn.
This is the answer to Chapter 21, problem number 8 from the Smith Organic Chemistry textbook. And this problem asks us to consider 2-butanone, which I've drawn on the left here, and diethyl ether, and to discuss why they have such a wide difference in boiling point. And so when we look at these two molecules, we see that they each have 4 carbons and 1 oxygen. And so we would expect them to have boiling points that were fairly similar, but it turns out that diethyl ether boils at a much lower temperature than 2-butanone. And so the reason for this has to do with the lone pairs around these oxygens. So we can go ahead and draw in the lone pairs. And there's really 2 things to consider here. So there is a lot more crowding around the oxygen in the diethyl ether. The oxygen is bound to 2 carbons, so there is less space for these electrons to occupy. So they're sort of stuck there, whereas in 2-butanone, the electrons have more room because the oxygen is not sort of in the middle of a carbon chain. It's sort of sticking out to the side. The other thing to consider is the effect of these bonds. So each of these oxygens is going to have a partial negative charge, so delta minus. And then each of the carbons that the oxygen is bound to is going to have a partial positive charge, so it's going to be delta plus. And so obviously in the diethyl ether, there are 2 carbons that are each getting a portion of this total partial positive charge, whereas in 2-butanone, the carbonyl carbon is double bound to the oxygen, and so it's going to solely have this partial positive charge, and it's going to be a stronger partial positive charge. And so one thing that we can imagine is, a second molecule of 2-butanone could line up sort of just underneath of the first molecule. And if they sort of stack like this, this oxygen will be attracted because this oxygen is also going to be partially negative. So it'll be attracted to this partial positive. And then again, there will be a partial positive down here. And so this could sort of stack indefinitely like this. And so that's a strong intermolecular attraction. And there's not really any comparable intermolecular attraction in the diethyl ether. Again, because these carbons are not as strongly partially positive, and they're not spatially arranged as nicely as they are in 2-butanone. And so that difference in intermolecular forces is significant enough to account for the significant difference in boiling points between the 2 molecules. And that is the answer to Chapter 21, problem number 8.